Hi, everyone, and welcome to my project description for Project 9. This is the quadcopter project in which we are downloading inertial measurement units, roll, pitch, and yaw data via Bluetooth from an RPI, Raspberry Pi, that is. And so really this project is a continuation or an extension of sorts from Project 8 last week. Really the key difference, or really the main difference in general, is the use of Bluetooth rather than Wi-Fi as the communication interface to the host PC. It's still, the same combination of hardware and software for the most part necessary to capture yaw, pitch, and roll data using the BNO055 IMU. That IMU is still connected to the same Arduino Uno I used last week. That is communicating with the IMU via an I2C interface. From there, the Arduino transfers the IMU data to the Raspberry Pi using a basic serial interface. And from there, the Raspberry Pi can do whatever it wants with the IMU data. For the purposes of my project, I'm storing that IMU data to a file. And so that will allow me to then send that IMU data packet or data file over to my host PC via Bluetooth. And I'll kind of demonstrate how I do that. So really, the overall goal for this project is to attach, everything that's just mentioned to the quadcopter. In my case, all those components just stayed on the quadcopter the whole time. And this time, the only difference is that my host PC is going to get the IMU data via Bluetooth instead of via Wi-Fi. And that's reflected in the requirements that I've captured here in my document. Really, the only change, as mentioned, is sending the IMU data from the RPI via Bluetooth to a host PC instead of via Wi-Fi. The other kind of derived requirements are, again, notionally all the same from last week. Still using application embedded software running on our Arduino Uno microcontroller, still using the IMU, still have a host PC, which is just this laptop I'm recording this video on. I have the Raspberry Pi microcomputer and the quadcopter itself. I'm getting yaw, roll, and pitch data in degrees, and that is all streaming serially at a frequency of about 10 hertz, so it's quite quick. And I also have calibration status of the various sensors within that 9-axis IMU, which is the gyroscope, the accelerometer, and magnetometer. And then finally, I'm recording all IMU data collected by the Arduino to a file, and then I'm transmitting that file to a host PC via Bluetooth. The design of the system, again, as I just mentioned, all the same as last week. The only difference is this interface between the Raspberry Pi and the host PC is now Bluetooth instead of Wi-Fi. In order to facilitate that, there are a number of packages that I'm using, software packages rather. They're all still off the shelf, but they are different from what I was using last week, which was RaspAP to set up a wireless access point and give me the ability to connect my laptop directly to the Raspberry Pi and then VNC over it to it via its wireless access point network that I created with RaspAP. In this case, I'm using Bluetooth Blues, which is a meta package, as I understand. There's a ton of documentation on this on Debian, but really it's a meta package that provides all of the different plugins supported by the Blues Bluetooth stack. I'm using version 5.55-3.1, and to my knowledge, that is all actually provided within the Raspberry Pi OS full version that I have been using for all of the projects to date. So really, I didn't have to do anything to get this installed. I did make sure to update and upgrade all the packages. So I believe this is one of the more up-to-date iterations. Its release date is June 10th. 2021, as far as I can tell. I'm also using Blueman. This was just for ease of use on my side. I was struggling with a command line interface with the Bluetooth Blues meta package for a little bit, just trying to get off the ground. So I decided to use Blueman instead. I saw, some Google searches hit on Blueman that gave me, or that gives it a little bit of a nicer GUI to interact with. So I can transmit data files over that Bluetooth interface. So that's why I'm using Blueman here. It's not required for this project by any means, but it's just a more simple user interface for me to use. So that's why I liked it. I'm using version 2.1.4. It's a slightly older release. I think there's a newer version out there, but for now I'm using 2.1.4. Same thing with PuTTY. I believe there's a newer version, 0.78. I'm just not happening to use that version. The version I'm using is 0.74, which was released back in 2020. PuTTY here is just my serial monitoring application, so I can grab the serially transmitted IMU data from the Arduino on the Raspberry Pi. So those are the kind of canned software packages that I'm using. You know, your typical sudo apt-get install, PuTTY, Blueman, Bluetooth Blues was installed, but I did it anyway. And so I'll talk about some of those Linux terminal commands in just a moment, but these are the software packages that I'm using. I kept this description in there for the Arduino IMU code, specifically the FreeRTOS architecture that I'm using, which is just a carryover from last week's Project 8. I decided I would leave that all in there because there's no harm in it. It does what it needs to do, and might as well keep it going and unchanged for this project because there's no reason to change it. So I won't bore you with the details of that. If you're curious, you can go to my Project 08 video and description. Very similarly, in terms of implementation, this is all the same. All the hardware has just carried on forth from last week's project. The webcam, RPI4 with case, Arduino Uno, the BNO055 IMU on a little, the Arduino doesn't call them hats, they call them shields. This is a little breadboard shield. I just have the IMU mounted there. Couple more photos of what everything looks like. It's starting to become even more of a mess of cables. Just the same as last week. I probably got to work on cable management a little bit, but everything is free and clear of the propellers and motors. So, you know, the quadcopter flies just as intended. I won't bore everyone with the details on the Arduino software. As I mentioned, this is just a carryover from last week. This is me using some example code from FreeRTOS and combining that with the Adafruit sensor and Adafruit BNO055 libraries. So that's all kind of combined in there, and it is working fully as intended to give me the yaw, pitch, and roll data and the individual calibration values as well, which is just convenient to have. And then finally, the terminal commands that I'm using to get all the necessary software packages on the Raspberry Pi are described as such. Sudo apt get update, sudo apt get full upgrade. That's just, you know, to make sure that all the apt packages, that apt package manager has everything up to date and upgraded. And then I'm installing Bluetooth, Blues, and Blueman. Again, Bluetooth and Blues should have been on there from the get-go, but I, you know, included it in the terminal command regardless when I was getting Blueman, just to make sure that, you know, I get the latest and greatest. So that's how I got Blueman. And of course, I already had PuTTY installed on my Raspberry Pi from previous projects, but this is the terminal command to get PuTTY. And so with that, I have all the pre-canned software on the Raspberry Pi as needed. I have the Arduino software already flashed on to the Arduino Uno from last week, and that means we're pretty much ready to go. So what I'm going to do here is now cut the video. This is just the intro description of the project itself. I'll do a quick little demonstration at my desk for how I am collecting the IMU data, storing it to a file, and transmitting it to my host PC via Bluetooth. And then I'll go ahead and do that again with a live flight demonstration. So look forward to that. So I'll see you in just a bit. Thanks much. Hi, everyone, and welcome back. This is my little pre-flight demo of how I can collect IMU data to a file on my Raspberry Pi and then transmit that to my host PC here. So what you're seeing on the screen should hopefully be my VNC viewer. This is just connected to my Raspberry Pi over Wi-Fi, just the local IP address that I have. And I just double check to make sure that I have everything hooked up correctly. My Arduino is this ACM0 device here connected to the Raspberry Pi, and I can connect to it via PuTTY. So I'm just going to go ahead and demonstrate that right now. I have my Arduino Uno already pre-saved here, ACM0, baud rate 115, 200. I'm going to log all the session output to a file, and I'm going to do that to my desktop here just so I know where it is. I'm going to go ahead and open that up. And I'm going to overwrite the previous file, and you can see here that I am now collecting IMU data on my Arduino, and that's getting transmitted serially to my Raspberry Pi. Now, just to start here, the gyroscope is calibrated because it was sitting for just a few seconds here. It is not calibrated for its accelerometer or magnetometer. I'll go ahead and pick up my quadcopter now. You see all the measurements change, and I will calibrate the magnetometer by waving the quadcopter around wildly. And then now I can point my device. Sorry, I don't have my camera on. My laptop's webcam has been on the fritz. But I can now, if you look at the yaw measurements, it's sitting at 92 degrees at the moment. I'm going to go ahead and yaw the quadcopter counterclockwise, and that's bringing the yaw degrees down. I'm going to move it now another 45 degrees in the opposite direction, and so that brings me, 90 degrees in the opposite direction, and that brings me up to about 180 degrees. And so that's yaw. Pitch, I'll try to get this level to start. That's around level. I'll go ahead and pitch upwards by 90 degrees, and there you see that. And then I'll go ahead and pitch downwards 90 degrees, and you can see that. And then I'm going to go ahead and roll the device. I'll get it stable again right around 0. Roll the device 90 degrees, and then bring it back level. Roll it 90 degrees again in the opposite direction, and bring it back level again. And I'll go ahead and sit the quadcopter down. And so all the while, Putty is storing this to file, and I'll go ahead and end this session and open up the IMU data. I'm going to open it here with a notepad. Sorry, my VNC communication can be a little bit slow sometimes. Looks like it's a little bit frozen. I'll open this first. And there we go. A little bit of awkward corruption of the data there to start. But then you see, as I scroll here, it was going at a pretty high frequency. You can see here the yaw values as I was yawing the quadcopter. Then I went into pitch, and you can see it started level, and then I started to go up to like 90 degrees in pitch, and then I went level again, right around there. And then I pitched downwards to about 90 degrees. Then I got the device steady, and then went into roll, rolled the device 90 degrees in one direction, got it level again, and then rolled it 90 degrees in the opposite direction. That's why you see the negative sign there. And so that was yaw, pitch, and roll as demonstrated as a pre-flight demo. And so now I'll go ahead and get this IMU data file transmitted to my host PC over Bluetooth. And so my host PC is running Windows 10. So the way I do that is I go to Bluetooth and other devices, go to related settings, send or receive files via Bluetooth. I just click on that. That brings me to this little window here, and I can wait for a connection. And here is the magic of Blue Man, which is terrific. It's the reason I like it. Blue Man here, I can send files to a device. I can click on that. I can just pick up this recent file, files to send, and hit OK. And then select the device. This is my desktop. I'm going to hit OK there, and it's going to transmit it. And there we go. I'll just save it to my downloads folder. So I have received this file. I'm going to finish it. Oops. Oh, I already have that file. I've done this before. I'm going to replace the file in the destination. And double check my downloads here. Confirm that I have my IMU data file transmitted as of 12:37 p.m. That was just a minute ago here. And I'll go ahead and open this with Notepad++. So I can demonstrate that I have this file open transmitted. And so here we are again, that same corruption that I just demonstrated. I started calibrating the magnetometer, and that's when the magnetometer got calibrated. I apologize. Sorry, I'm just getting over COVID, so I still have a bit of a cough. I then went to test yaw, pitch, and roll. And so this was me testing yaw here. That's how I got to 180 degrees yaw. Then I went into testing pitch, I believe. So I stabilized right around there, pitched upwards 90 degrees-ish, then got back to steady, then pitched downwards 90 degrees-ish. Then I got steady and started rolling. Oh, there you go. That's when I got steady to roll. Rolled 90 degrees in one direction, got steady, and rolled 90 degrees in the opposite direction, -90. And so that is the demonstration of a pre-flight demonstration, rather, of yaw, pitch, and roll on my quadcopter, saving the data to a file and transmitting that over Bluetooth to my host PC, where I now have it. All right, so with that, I'm going to go ahead and clip the video here and move over into the live flight demonstration of all of this. So thanks, and I'll see you in a moment.
Hi, everyone, and welcome back. So I'm going to do the live flight demo now. I'm going to go ahead and start up PuTTY. And so I have that already as a saved session. I'm going to save all the session outputs to a IMU data text file that you see here. I'm going to go ahead and open that up and overwrite any previous files. And you can see it starting now. So I have yaw, pitch, and roll. I'm going to go ahead and pick up my quadcopter and calibrate the magnetometer, which you see now. Now, yeah, there you go, fully calibrated. And so here I can just once again demonstrate yaw in both directions, pitch upwards, pitch downwards, and roll from side to side. There you go. And so now the quadcopter should be ready to fly, and you should be able to see these values update in real time. And so now quadcopter is ready to fly. And there is the live flight demo. And so I'll go ahead and close out this session of PuTTY and transmit that data here to my host PC. We're going to set it up to receive files, just like so. And with the power of Blue Man, I'm going to send those files straight over to the host PC for display. And so I'll transmit that here to my laptop computer, or this desktop here. And you can see it has transmitted the data. So I'm going to go ahead and finish and replace the files in my destination. And so if I go over to my downloads folder, you can see that this is the latest file as of 1:15 p.m. I can go ahead and open that with Notepad++ and watch the IMU data propagate. And so here we are, Notepad++. This is the yaw, pitch, and roll data. You can see I started by calibrating the magnetometer, and then I got into flight, and the yaw, pitch, and roll data didn't really change much. For the most part, I was just trying to keep the quadcopter steady so it didn't fly away. And so that's what you're seeing here when it was back grounded again. This was some of the yaw, pitch, and roll data in flight. You can see the pitch values changing slightly, the roll values changing slightly, even some of the yaw values changing slightly. But when it was grounded, it was then held steady at these values. And so that is the live demo and the transmit of data files over Bluetooth. Thanks much, and I'll now show or cut here and show the actual live video of the quadcopter in flight. Thanks much. And so now quadcopter is ready to fly. And there is the live